Hey everybody, Lars here. Time to do video number 1 for unit number 3 for Python methodologies in data science. I'm going to try to go through this quick. I know I always say this, but this time I'm going to. It should be fairly straightforward. Not going to clobber you with announcements. Probably getting this to you Monday night. I'm shooting it over the weekend, and I want you to have some time to read the Zell book, to look at the slides, to get an idea of what we're trying to accomplish this unit. Long unit, 3 weeks. Breaks down into 3 different sections, though, so if you do one a week, maybe front load that last one a little bit so you have some time for your assignments in the quiz, you're going to be okay. And you'll see when we get to the assignment that it's a good assignment for everything we've done in the last 7 weeks. It's like math. Programming is cumulative. You're always going to learn what you have learned the previous unit in the next unit because we're building a pyramid, building a base and then going up, up, up. Again, this is going to go long if I don't stop talking like that. All right, so we're going to jump right into it. We're going to start talking about the first third of your unit 3 slides, which is functions. So I already got some code up and running, and we're going to jump right in and look at functions. I want to go quickly, but I don't want to I don't want to go so fast that you don't get something out of it either. So I got to balance those two things. What I did right here really quick is I created a list. And as you guys know, you have been dealing with functions all along because Zell introduces them pretty quick. But you've been using things like type and int and float and casting things. And those are nothing but functions. And you'll see if I save this and I run it, it will give me the sum of all those numbers there just by doing the sum function. Now, sum is what's called a built-in function. They are loaded into memory by Python, and they are ready to go when you start using your program. And if we go here to Google, I'm going to type, if you ever need to learn anything about Python, you just type Python docs, and boom, you go to the Python documentation. Okay? So what I'm going to do is I'm going to say built-in functions. Go. Click on built-in functions, and I'm going to show you the built-in functions. Okay, as you can see, there's int, there's our casting. We just use sum, which is right there. If you click on it, it will explain to you what it does, how it does it, what the arguments are, what the return value is. We're going to get into anatomy in a second. Okay, do not use a val. Okay, I want you to use that. Use that. Don't use that. It's not good. It's not good. All right, so this is where you come to learn about the built-in functions. As you can see, there's not a lot of them. We don't, as I told you in the past, we don't want to bog down memory that much. Okay, we want to make sure Python is lean and mean and runs quickly. So we do load those particular functions, but not a whole ton. You're going to learn in the third part of this unit about the standard libraries and how we have to load those particular functions. But I am getting ahead of myself. I don't want to get too far ahead of myself. Okay. So that's basically us using a built-in function that is made for us. As you can see, as far as an anatomy of a function is concerned, the name of the function is sum. Okay. The argument list in this case is my list. We gave it an iterable or something it could iterate over. All right. And you can see the return values right here because we printed it, 27, which is just the sum of those particular elements in that list. Okay. This is all fun and this is all well and good, but what we really want to do is teach you how to create your own functions. That is the key. So what I'm going to do is I'm going to whip up a function really quick. I'm going to call it multi-cube. What I'm going to do with it is, as an argument, I'm going to take 2 integers. I'm going to multiply them together, and then I'm going to return the cube of that product. All right? You'll see what I'm doing. So I want to create my own function now. So how am I going to do that? I'm going to use the keyword def. That means define, and I'm telling Python, hey, I'm going to define a function right now. I'm going to give it a name. I'm going to call it multi-cube. When I name functions, I use the same conventions that I use when I create variable names, okay? Don't lead with a number. If you can, avoid punctuation. Definitely avoid double underscores. We're going to talk about that later, okay? So I just try to give it a descriptive name. I'll call it multi-cube. And I will take as variables an a and a b variable as integers, and then I'm just going to close the parens and hit my colon, saying that I'm about to do a code block. Okay, so now I'm in my function. I have an a and a b. What do I want? well, I want to multiply them. So I'm going to say z equals a times b. I can create that z out of thin air because I'm not considering it on the right hand of the equation anywhere. It is on the left hand, so I'm going to create it there. And now, truth be told, I just want to cube that value, and I can do that in my return statement. So I'm just going to say return z3. And you can see after I do the return, when I hit enter, idle shot me back out, so I'm not indented 4 anymore. Because after I do the return, idle knows, hey, that person is probably done with their function. Okay, you don't have to be. You can have multiple returns, but we'll get to that in another time. All right. So now I have a function. I used the def keyword. I called it multi-cube. I took 2 arguments, a and b, and then I used them in my body, and I have a return value, which is the cube of that. So what I'm going to do is I'm going to say main and say my main program, and I'm going to print multi-cube, just like I did with sum before, of 2 and 3. Okay? So what's going to happen? Multi-cube of 2 and 3. I call multi-cube of 2 and 3. I'm going to come up here. A is going to be 2. B is going to be 3. So 2 times 3 is 6. Z will equal 6. I come down here, return z to the 3rd power. 6 by 6 is what? 36? 36 by 6 is 216, I think. Let's find out. And there we go, 216. Okay? Now, everybody's like, oh, yeah, that's all well and good, but, you know, we could have done that logic in a regular program. Here's the key. Now, if I want to do something else, if I want to do 3 and 3, all I have to do is rerun multi-cube, okay? Because I have all that logic up there in my program already, all right? It's that simple. Program name is multi-cube, 2 arguments that I use within the function code, and then a return value. So down here, when I call the function 2 and 3, I come up here, the A maps to 2, the B maps to 3. When I call it my second time, okay, the A maps to 3, the B maps to 3, and I go through the logic again, and I return as a return value that particular item right there, okay? All right, I want to make sure everybody's cool with that, because now that I've showed you how to create your own function, I want to talk about 2 different aspects when we're dealing with functions. The first one is fairly simple to look at in this particular context. I'm going to rerun my code. I get my 216. That's great. Let's say I wanted to print z. Okay? Z's in my program. I come up here in my program and I look at z equals a times b. In this case, 2 times 3, it should be 6. Z should be 6. So I'm just going to print out z and hopefully get my 6. Okay? Think it's going to work out? Hold on a minute. Why isn't it running? Boom, 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 boom. We get a big old error. Down here it says name z is not defined. Okay, why do we get that error? We get that error because of a facet of using functions called scope. When I am writing a program, all right, as a programmer, I've got all of this memory that the program can use. We programming nerds call it the heap. And I can use all of that to hold my variables and to hold my functions and to do all of this stuff. It actually is where the program code is held as well. And that's where I keep all of my stuff, and my program can use that area. But what happens when I create a function? When I create a function, I go off to the side and I say, I'm going to run this like a little mini program. So I grab a little hunk of memory, and programmers call it local space. Okay? So when I'm going to change to that new place, and that's my local area now, and I'm going to do all of the work that I have to do. I'm going to take that A and that B, and I'm going to create a Z variable, and Z is 6, and then I'm going to return Z cubed and do all of that. But the problem is this. When I call that function, and it runs, and it's done, all of this goes away. Okay? That memory is, it goes away and it's gone. It's completely gone. So now that I'm back outside the function down here, Z no longer exists. Yeah, you say, well, that's kind of weird. It's right here in my program, but that doesn't matter. It's already run. This is just where the definition is. Okay? It's already run off to the side and returned that variable for you. So technically, Z doesn't exist out here. And that's why it tells you down here, name Z is not defined. Global space doesn't know about it. You went off to the side in local space, ran your function, returned the value, and then all of this is gone. Now, if I want to print Z, if I'm really dying to print Z, that's got to happen, then I can come up here and do it, okay? Because when I'm in local space and I'm in that context, well, then I can print it. I can print it all day long. You can see the 6 is right there, okay? So you can definitely do it there, but you can't do it outside here because after all of this is run, Z goes away, okay? As a matter of fact, I'll show it to you. All of those variables go away. They don't exist. Name A not defined this time because that was the first one that made it blow up. They're gone. All the variables we used in here are gone after we run the program, okay? Now, so that's scope. Look at the examples in Zell. Think about that because that's an important thing. When your function is over, the variables that you used in that particular function, they no longer exist either. It's like you ran a program, it returned a value, and now that's gone. And now it's all out of there. All right? All right, I'm going to do one more thing for us. For us on this fine, it's Saturday today. You're getting this on Monday. And it's gorgeous out. It's 65 degrees out. I was just out in my front lawn. My front lawn's a mess. I'm doing it again. I'm digressing, and I should be doing Python, and this is how videos go long. I apologize, but it is gorgeous outside. It's absolutely beautiful. I might go for a walk later. On my gimpy leg, I'm going to the orthopedist on Tuesday to find out if I need more surgery or not. I think something's growing back naturally. I really do. I'm able to do stuff that I don't think you can do without an ACL, and I'm doing it again. I apologize. All right, let's do this. First thing, I'm not interested really in printing that 6, but I'm going to leave it there. All right, let's look at this. I took away the print, and I'm running multi-cube 2 of 3, and I know it gives me 216, so let's run the code and see what we get. All right, we get nothing. Okay, but we didn't get an error. It seems like everything ran, but nothing happened. We ran multi-cube, and it went up here and it ran, but multi-cube doesn't have a print in it. And we don't print it here, so nothing really happened. There was internal logic, but nothing was shown to the screen, so we didn't see anything. This is an instance of us needing to capture the value of a fruitful function, okay? Because if I don't capture that value, I can't use it. Now, what we did earlier was we just printed it to the screen, okay? But what most of the times you're probably going to want to do is, and I don't want to just use A, I'll call it answer, is assign it to a variable. And then we can print it and do whatever we want with it or use it in another formula down the line. So now I'm running multi-cube with my 2 and my 3. It comes up here, does the logic. The return value is 216. And that's going to be assigned to a variable called answer. And then I can print answer. So when I do that, all of a sudden all is well in the world again. Okay? You need to be wary of that. Because if you don't print the value or you don't capture it with a variable, then it'll run, but it's almost like it's wasted. It's almost like you don't capture the answer, so you can't use the answer in your logic going forward. So you definitely want to make sure that you capture the value of fruitful functions. Some functions are void functions, like that little function we started with where I printed the first 4 lines of Detroit Rock City. That's easy. You run it, it goes and it runs off to the side, prints those 4 lines, and then comes back home. That's it. Okay? That you don't have to worry about capturing a value. There's no value to capture. There's no return. But when you have a return, you want to make sure that you're either printing it because you wanted to find it and print it, or you're saving it to a variable, okay? So when we deal with functions at first and we learn how to define our own functions, that's one thing. The 2 things that I want you to be aware of are scope. Know about scope. Know that you're in a global space. And when I run that functions, I'm going off and doing it on the side. Then I'm returning the variable or the value, and all of that goes away. Okay? Any temporary value or anything variable that I used inside that function goes away because it's out of memory. I ran it, got the value, boom, now it's gone. And the second thing is make sure you capture values when fruitful functions return them. Because you want to be able to use them, and that's the whole reason we're doing them, right? To capture them and use them in the future or print them out. So make sure you capture that stuff, okay? All right, we're in good shape. I believe we have looked at the anatomy of functions. We've looked at some built-in functions. I showed you where the built-in functions are in the documentation. Then we learned how to build our own. We have the def keyword. We name functions like we name other variables. We have the name of the function. We have the arguments that the function uses to do its work. And we have a return value. That's pretty much what we call the anatomy of a function and how functions work, okay? And then lastly, we looked at two different aspects of functions. Scope, okay? Know that it runs off to the side, and when it comes back, all of those variables inside of the function are gone. And also know about capturing values as far as fruitful functions are concerned. So we could either print or capture those values to be used later in our program, all right? Great. So we've gone over that. There's one more thing I want to do. First off, I'm going to do this. This doesn't even lend itself to a good, I got rid of the print. How do I undo that? Hey, undo worked. All right. Grand finale? Why not? Not a very interesting one. But I'm taking this code and I'm going to put it in your Sakai resources. So when you first get this video, you're going to have a copy of funcs.py if you want to look at this, play with this, and use it as an example, okay? Now, one last quick thing that we're going to do, and I already set up a shell for it, is we are going to reconsider the 6th problem at Project Euler now that we know about functions. Because if you remember, the 6th Euler problem was you want to take the sum of all the squares from 1 to 10 when it was first given to you. And then you want to take the square of the sums of 1 to 10. You want to find the difference of those numbers, and that's the solution you're looking for. And then what we did was we coded it up and did it for 1 to 100. When we did this, we only knew about simple data, decisions, sequences like strings and lists, and loops. So basically our powerful tool was to use loops to do it, okay? Now we have functions. So how would we rewrite that program knowing now that we have functions? Well, if you think about it, Euler 6 isn't one problem. Euler 6 is 3 problems. I need to find the square of the sums, I need to find the sum of the squares, and then I need to find their difference. So when we have a big thing that can be compartmentalized and made into little things, a lot of times using functions is a good way to attack something like that. So I'm going to say def, and the first thing I'm going to do is I'm going to look for the sum of squares. I will take n as a limit, and what do I want to do? I'll just use a temp variable called s, I'll make it 0, and I'll say for I in range 1 is where I want to start, and then I want to go to what? N plus 1, because that's the first thing I don't want, and then I'm going to make s equal to s plus the square, okay? And there I go. Then I'm going to return s, right? Think about it. Boom. Def, I'm going to define a function. I'm going to name it sum of squares. I'm going to take a limit, all right? And then I'm going to use my loop inside of it, and I'm going to loop around, and I'm going to find the sum of all the squares from 1 to my limit, okay? And then I'm going to return it, all right? So let's check that out and see if it works. All right, sum of square, and I'll just say 10. And I come down here, and I run print, and it says 385. If memory serves, I think that is correct, okay? So we're in good shape. Now, watch this. I'm going to copy, and I'm going to paste, and what do I want to do now? I want to do square the sum. So how I do square the sum, I'm going to rename it SQOS, okay? I'm going to use the same logic, but down here, instead of squaring it, I want to just add everything up. And then when I return, I want to square it. So look at that. With just those little changes, in less than 10 seconds, we now have a square of the sum. Okay? So now I come up here, comma, I'll say square of sum, 10, and I'll run it. And 3025, you know what? I believe that's correct as well. So now I've got one problem licked, sum of the squares. I got another problem licked, square the sums. So what do I want to do? I can do it right here in the print line. The diff is space, comma, I want to do square sum 10 minus that, right? So the difference is 2640. And if I'm correct, and I think I brought this up, yes I did, 2640 right there. Don't worry about the color. I'm logged in as myself. Okay, so we'll do the 100 and see if we get the answer. But 2640 is what we got last time, so we know 2640 is good. So now what do we have to do? All I have to do is change these to 100s. Okay? But I don't like that. You know we're going to change this in a second. So I do 100 versus 100, and what do I get? 251, 64, 150. 251, 64, 150. Same thing here. Okay? But my programmer OCD will not allow this at all. Limit equals 10. Limit and limit. If you can use variables so that you only have to change values in one spot, you do it. You do the extra work at the beginning. So now I have 2640 there, and now I add 10 and 10, and then I redo it, and I get the good answer there. Okay? So consider what we did before, the first time we did it, and now look at this little piece of code right here. To my programmer brain, this is more efficient to me because I compartmentalized my logic. I wrote a function to take care of one part. I wrote a function to take care of the other, and because I don't really, I could also write a function to do the difference, but why? I can do it right here in the print line, okay? And I did it so that I could actually create this so that the user could input it. We could do it that way as well, okay? So now I have functions. So now I have all the tools I need to find the answers I want to get. I have simple arithmetic. I can play with variables. I can make decisions with if, else. I can do lists and strings. I can work with loops, be it for loops or while loops or whatever kind of things. Now I have functions. So I can compartmentalize all this logic out and do what I did here and break things out, okay? So Euler 6 WF, you'll see with functions, will also be in your Sakai resources. So you can look at this and play around with this, okay? And also remember, keep going to Project Euler and playing around with that, okay? Because you can now take what you know about functions and start building some more powerful programs. And later in this unit, in a couple of weeks, you're going to learn how we're going to take these functions and we're going to put them in big files full of just functions. And those are libraries. And all of this logic, you keep it. I would never have to write this again. Okay? If I wanted to just use this in a program, I would put it in a library. I would import it from that library, and I would use it. And this program would instantly become just a 2-line program because I have already written the logic for this. Okay? We're all about code reuse when we're computer programmers. All right? All right. Then I am putting this in resources. As I said before, I am not going to kill you with announcements, because right now you all did a great job. You got all of your stuff in on time for Unit 2. Hans and I are going to take the next week and we're going to grade the assignments. I'm going to read your forum posts. I'm going to do your quizzes. And then hopefully in a week, maybe a little more. Don't freak out. That was my dryer. Saturday is also laundry day. And I'm going to get you all of that stuff. Right now, first week, I want you engaging with the resources. Read your Zell chapters. Read the slides. Watch this video. Hopefully in 2 or 3 days, maybe 4, I don't know what my schedule is going to do to me, I'm going to get you the second review video. Then I'm going to get you the third video, probably a little quicker than I usually do, and the programming assignments, because the assignment, this particular unit is a big boy. I have you do a function, but then the second assignment, I have you read random numbers from a file, and then you're going to have to examine those numbers and use 2 functions that you keep in a custom library to winnow down that data set to a smaller data set, and then you're going to do some math on that data set, all right? You're going to like it. It's a fun assignment, and at the end of the day, because it's the kind of assignment when you're done with it and you get it working, you're going to be like, yeah. And you're going to need all of the skills you've learned up to now, because you're getting, if you think about it, Unit 1 was 2 weeks, Unit 2 is 2 weeks, this unit is 3 weeks, and 7 weeks you are getting the basics of imperative Python. That's it. After this unit, you're going to know Python. You're going to know the basics of Python. Then when we move forward, you're going to use it. You're going to use it for CS. We're going to learn about object orientation. We're going to do a little bit with data structures, okay? All right. Then I'm going to get out of here. Like I said, I'm not going to clobber you with announcements. I think everyone in the class is doing great. I don't have to chase people around. Hey, do your quiz. Hey, do this. Hey, do that. So I'm loving this bunch. I think this is a great class, all right? You guys be good. I'm going to talk to you soon. Take care. Bye-bye.